This recording is to help you with lesson 10.01 on Introduction to Conics, and we're going to start with parabolas. Now, we should be pretty familiar with parabolas because we've worked with them a lot in the past, especially in Algebra 1 and in Geometry and Algebra 2 a lot. Remember, parabolas are like your upside down, or your U's, or your upside down U's, and now we're going to kind of talk about them if they open left or to the right. They're your quadratic equations. Okay, so you have to have a variable that's squared somewhere. Okay, so we're going to focus first on finding the vertex, focus, and the directrix of a parabola, and then sketch its graph. So what we're given that we have x squared plus 8y equals 0. Well, we kind of want to isolate the squared term in any variable that has that. So notice that x squared. We want to isolate the x's on one side and the y's on the other. So to do so, we're going to start by subtracting 8y from both sides. So that gives me x squared equals a negative 8y. Okay, I want to write it so this constant, whatever it may be, is 4 times something. Okay, this will help me a lot to find the value of p. Okay, so I know it is 4 times negative 2. That will give me my negative 8. Okay? And now I can start picking up the information that I want. Looking down here, it kind of matches up with this last one here, because p, if we look here, p is negative 2. Right? So p is less than 0, and the x is the squared variable, so we're following this information. So the center, or the vertex, not the center, the vertex is your opposite x, opposite y. Well, it just so happens that we have 0 and 0 for each one. And then we know that p is negative 2. So to find the focus, we use h comma k plus p. So if h is 0, we know k is 0 and p is negative 2. So that gives us the point 0, negative 2 for the focus. And the directrix is just y equals k, which we know is 0, minus p. And we know that p was negative 2. So here we actually have y equals a positive 2 for the directrix. Alright, next, there are times when we are going to have to complete the square. So again, I'm going to get all the y's on one side and the x's and the constants on the other. So here I would start off by taking y squared plus 6y, and I would subtract off the 8x and the minus 25. Okay. That would be my first step. Now I need to actually complete the square here. So remember, we take half of the middle term. So half of 6 is 3, and we square it. 3 squared is 9. We add 9 to one side, we have to add 9 to the other. I can then factor the left-hand side. That's just y, and then whatever half your middle term was, we said that was a positive 3 squared. Let's simplify the right-hand side. A negative 25 plus 9 is a negative 16. I notice that I can take out a negative 8 from both the negative 8x and the negative 16. That would just leave me with x plus 2. And remember, I want to write it so it's 4 times something. So this is 4 times negative 2. Just to kind of help us determine what p will be. Okay. So pulling out all the information I'm going to need now, I need the value of p, which I know is negative 2. I need my vertex. The vertex is going to be the point, let's see, we start with the x, so the opposite of x right here is negative 2. And then we look at the y, the opposite of the y is negative 3. So this is my vertex. And let's see, we have the y squared, so it's one of these. And I know that p is negative, so I am using the highlighted portion for the formulas. Okay, let's start with the focus. We're going to do h plus p. Well, h we knew was -2 because that's the x value of your vertex, and p we know is -2, and k is our -3. So our focus is going to be at the point -4, -3. Now the directrix, let's see where the directrix is. I'm going to just abbreviate that as DIR. Okay. Directrix following this is x equals h minus p, so -2 minus a -2. If we add those together, you get x equals 0 for the directrix. For our next one, number 21 here, let's start by getting rid of the fraction because this is not in our standard form that we want. So let's start by getting rid of the fraction in front of my parentheses here. And to do so, I'm going to multiply both sides by -6. Okay? So if I multiply both sides by -6, I'm at this step right here. Okay. Because the x is squared, let's have the x's on one side and the y's and the constants on the other. So that means I would have to add 2 to both sides. So right now, I would be at my -6y plus 2 equals x squared plus 4x. Okay, I need to complete the square over here on x squared plus 4x. So we take half of the middle term, so half of 4 is 2. I'm going to just move this real quick. Okay. And we square it. 2 squared is 4. So if I'm adding 4 on one side, I have to add 4 on the other. So that leaves a -6y plus 6 equals x plus 2 squared. And I'm going to factor out a -6 here because I want y to be positive if it can be. Okay. Here's kind of the tricky part because we do want to write that 6 as 4 times something. Right? So -6 equals 4 times something. We have to figure out what that value might be. So if I divide each side by 4 and then reduce, I know that that value should be my -3/2. So that's how we get 4 times -3/2 here. So basically we just rewrote the -6 as 4 times -3/2. Okay. That part can get a little bit tricky. This is now written in a form that we can pick things out from our table. We notice that x is the squared term and p is negative because it's -3/2. Right, so we are using this highlighted portion. I know that the vertex is a -2, -1. So I know h is -2 and k is a negative, it should be a positive one. Oh, when I factor out, oopsie daisy. When I factored out my minus sign, I forgot to change this here. So this, in fact, is a minus in here. Okay. Minor details, that's all right. Simple mistake. So we do get k to be a +1. Okay, so the vertex is -2, +1. To find the focus, we use h, comma, k plus p. I'll do this one in purple or pink here. So h we know was -2. K we said was 1, and p is our -3/2. So that leaves us with the point -2, -1/2 for the focus. And then my directrix is y equals k minus -3/2. That really turns into a plus sign here. So that would give us 5/2, or 2.5. Y equals 2.5. For the next one, we need to find an equation of the parabola if we're given this information. All right, so the vertex is 3, 2, so that we know that h equals 3 and k equals 2. I know my focus is 1, 2. Okay, so I know that the y's are staying the same. So if I look here, the only time the y's are staying the same between the vertex and my focus is if it's y squared. So I know it's one of these. And to find p, I take my focus minus my vertex. So 1 minus 3 is negative 2. So that's how I get p to be negative 2. Okay. I know that I'm now using, since p is negative, I'm using this row here of formulas. So I would use y minus k, and we know that k is 2, equals 4 times p, we know p is negative 2, times x minus h, and h we know is 3. So really, if we want to just kind of simplify this a little bit to clean it up, 4 times negative 2 is our negative 8. So here's the equation that we can create, given that information. Okay, the last one that I'm going to go over real quick here is the path of a softball is given by the equation here. It is a quadratic equation, so I use my graphing calculator to look at the graph. Okay. Here's the trajectory of the softball. It says move the cursor along the path to approximate the highest point in the range of the trajectory. All right, so that's the highest point right here. And my y value appears to be about 7. So 7.1, anything like that, 7.09, 7. As long as you're around that vicinity, your answer should be okay. So that's the highest point, and the range then would be your y value. So y is less than or equal to 7.1, or whatever you decided to use there for your highest point. Okay, so that's the highest point, and then the range is y is less than or equal to that. So you can have a value less than that for the softball.